Our first shape that we're going over today is a parallelogram. So like the name implies, the opposite sides have to be parallel. And that's the definition for a parallelogram. Opposite sides are parallel. Then if you measured these sides, you'd find out that PA and LR are congruent and PL and AR are congruent, that opposite sides are congruent. And if you measured your angles, you'd find that angle P and angle R are congruent, and that angle L and angle A are congruent, so that opposite angles are congruent. Now remember that when you have sides that are parallel, you know that you will have different angles that are congruent or supplementary. Remember that when you have alternate interior angles, they're congruent. And when you have same side interior angles, they are supplementary. Which means they add to equal 180 degrees. And that last one, the same side interior angles being supplementary, is part of our properties. Angle P and angle L would add to equal 180 degrees. Angle L and angle R would add to equal 180 degrees. Angle R and angle A would add to angle 180 degrees. Angle A and angle P would add to equal 180 degrees. So our same side interior angles are supplementary. And then our last property is about our diagonals. And you'd have to draw them in and then measure the two separate parts. And it's that they bisect each other. Now remember that bisect means it cuts in half. So they are literally cutting each other into two congruent parts. So there are no lines of symmetry in a parallelogram because when you fold them anyway, it doesn't line up 100%. So next up, we want to fill in the different angles and lengths. Our first angle that we are looking for is angle BAD. BAD. So this corner, and we can add 89 and 36 together. And when we add 89 and 36 together, we get 125 degrees for that entire angle. And because that angle is 125 degrees, we know this angle down here, angle BCD, is also 125 degrees because opposite angles are congruent. And that is for this whole angle, not just one part of it. And then we need to look for angle ABC. So ABC is this angle. Remember that our same side interior angles are supplementary. So we can subtract that 125 from 180. And when we subtract 125 from 180, we get 55 degrees. And that's the measure for angle ABC. And that's this entire angle is 55 degrees. And that means that this angle down here, angle ADC, is also 55 degrees. So now we are looking for angle 1. Angle 1 is not 55 degrees, but it is part of a triangle that we do know two angles of. So we can take that 124 and 36 and add them together and get 160, and then subtract that 160 from 180 and get 20 degrees for the measure of angle 1. Now I know my alternate interior angles are congruent, so that means that angle 5 is also 20 degrees because angle 5 and angle 1 are alternate interior angles. And I know that angle 1 and angle 2 have to add up to 55 degrees, so I can subtract that 55 minus 20 and get 35 degrees, and that's the measure of angle 2. I also know that angle 2 and angle 6 are also alternate interior angles, so angle 6 is also 35 degrees. Now I know angle BAE is 36 degrees, and it's an alternate interior angle with angle 4. So angle 4 is 36 degrees. And 89 degrees is alternate interior angle with angle 3. So angle 3 is also 89 degrees. Then I know that angle 8 is a vertical angle with 124. So angle 8 is 124 degrees. And then I know that angle 7 and angle 8 are supplementary, meaning they add up to 180 degrees. So I can subtract 180 minus 124 and get angle 7. That's 56 degrees for angle 7. Now we're looking at lengths. So first off, we're looking at DC. And DC is this side, and it's parallel and congruent with AB. So it's 10.8 centimeters. Then I'm looking for BE. BE is here. And BE is part of our diagonal. And remember that diagonals are congruent, or not congruent, diagonals bisect each other. So what's on one side's on the other. So this is 7.7 centimeters. And then we're looking for EC. EC is this length. Again, it's on one side, it's on the other. So it's 4.5 centimeters. And then I'm looking for BC. Where's my B at? B is up here at the corner. So we're going B, hope not in, but on the side. B down to C, which is parallel and congruent with AD, which is 6.4 centimeters. Then we're looking for BD, which is from corner to the opposite side. We've got 7.7 and 7.7. When you add it together, you get 15.4 centimeters. And then last up on this one, we're looking for A to C, which is all the way across, 4.5 and 4.5 gets us 9 centimeters.